Okay, hello, how's it going? I wanted to do one more intellectually serious video for the time being. I want to load object models with WebGPU. I'll just open up the folder that I've got here, and in the distribution folder as well as the textures over here, I've also got this models file, and I've got two models. This ground model is just a very small file that's easy to read, so I'll be using it for debugging purposes, and this statue model is the actual file that I want to load. So I'll just open up the ground object model. No, don't open it with Xcode. Oh no. Okay, this will just take a second. There we go. Okay, cool. And while I'm at it, before I fire this up, I'll just run npm start to install the dependencies. There we go. Okay, excellent. So, loading files, loading object models. As we can see here, this is the object model format. We have a bunch of these lines, and these extra like metadata lines, we can just ignore those. This object line, we can ignore that. I'm just going to assume that every model I load only has one object, keeps things nice. So in other words, I'm staying well away from GLTF. It's a nightmare. We'll get back to it at some point. Okay, so what I'll do is I'll just open up the view folder, and I'll just make a new file called object mesh.typescript, and I will grab pretty much, let's go everything that I've got in quad mesh, grab that, bring it over, and just modify it. Okay, so one thing I'm going to need is, as I load these, if we look at this V, this defines a position, and it has, just close this down for now, it has three components. So I'll need a vec3 for that. And then this VT is a texture coordinate. It has two components. So long story short, I'm going to need to import vec2 and 3 because I want to keep a list of those active. So if I look at my fields here, I have buffer layout. I'm also going to have, I'll call this V. It will be an array of vec3s, and VT will be an array of vec2s. Now I'm actually not going to use normals at this point, but I will load them in anyway just to show how it works. And it'll be no problem later on when I want to use normals in my rendering just to bring that data in. Okay, so if we look down here, we have this vertices is a float 32 array. So let's store one of those as well, and we'll build it up as we go. So I have vertices, that will be a float 32 array. And also I'm going to keep track of the vertex count. Okay, now the constructor will be incredibly simple. For the constructor, I will literally almost do nothing. Maybe just set some of these to empty arrays. And then I'll change this to an asynchronous function called initialize. Now that should be this, shouldn't it? Now the reason I'm making this asynchronous is that, similar to the material file, I'll be using the what is it? The fetch response sort of format. So what am I thinking? So I'll take the device and the URL for the model I want to load. That'll be a string, the file path. And I'll make a function down below. Let's be an asynchronous function, and I'll just call it read file. Okay. So that will do, oh, what are we doing here? That will do what it needs to do. Up above, I don't need to worry about vertices. All I'll do is await this read file, and I'll assume that by the time this function has run, the vertices will be populated with all of the data that we need. What we should do as well is calculate the vertex count. And the way we can do that is take the length divided by 5. Okay. Of course, we do have some little errors here because now I've moved it from a function level variable to a class level variable. So I just pop through, put that in where I need. Okay, no, that's fine. Okay, so. Now I'm going to, let's go. I'm going to declare an array of numbers, and then right at the end of the function, I'll construct that. So I'll go this vertices equals new float32 array based on result. And the reason for that is that this vertices is sort of a fixed array, so we don't really have an append or a push function. I mean, we do have some other things, but it's just, yeah, why? Whereas the result is a dynamic array. So we can go result, push, and we can put in numbers. So think of it like we build this up and then we bake it down and store it. So now onto the issue of reading the file. Now, when I was constructing this, this was the hardest part. So at every stage here, I just want you to imagine me console logging a whole bunch of results and Googling a whole bunch of things. But here's how we do it, more or less. So we go to the material. And when I say here's how we do it, I mean here's one way we could do it. So what did we do with the material? Well, we took that URL, the string, and we ran a fetch request on it. And then we got some response back and we could query the blob, all of the data in there. Now, it turns out through a bit of experimentation that we can do some other things with this besides turning it into an image. So I'm going to call this file contents, and we'll go call, whoops, not blog, blob.text. Now what this will do is, yeah, it returns a promise to a string, and by awaiting it, that ensures that we then have a string. So this will basically fetch the file that we specify and then grab its contents and throw them back at us as one large string. So then what we can do is split that out. So we go file contents, split, and the splitter will be the, oops, wrong slash, the new line function. I never remember whether it's a backslash or a forward slash. Is this slashing back or forwards? I don't know. Anyway, so now we have, if you imagine this file has been split out into an array where every element is a string. So we can then run a for each loop on that. So we'll go lines for each. And then the way this goes is we have take the line as our input, that's the temporary variable, and run this function on it. And now what I want to do is I want to deal with these things. They'll either be, the lines I'm interested in are the ones starting with V, VT, VN, why not, and F. So I'll just write some functions down below, which I will call based on what I see. So I'll have read vertex line. And this will be probably a little different on the GitHub. Just from memory, I think I called it read vertex data. Doesn't matter, it's the same thing. We're reading a line of data which describes a vertex. And then we'll have normal line, and then finally a face line. Okay, but with the face line, I also need to take in as an argument the thing that I'm writing back to. So that's result, which is an array of numbers. Okay, so let's start with that. So I'll say, all right, I'll do a whole bunch of if-else. So I'll go if line 0. Okay, so if we have a V and a space. Now it's sort of important to check for the space as well, because as you can see here, otherwise the VTs and the VNs would be false triggering this condition. And as with everything, there are heaps of different ways to do this, but this is the way I chose. Yeah, otherwise, let's go, what do we do if we have a VT? That's a text coord. And then similarly, we could have a VN. And then finally, we have a face. And as far as I can see, there's only one sort of line that starts with an F, so that's fine. We pass in the line and the result. And array objects are sort of passed by reference, so it doesn't matter. We can take this in, we can write to it, and that will be stored in this variable. Okay, so what happens if we get vertex data? So what I want to do with the vertex line is break it down into its individual components. So I'll go const components. We have split that based on the space. So then if we look at this, we would have an array where the first thing would be the letter V, and then we'd have some number representing the X coordinate, some number representing the Y, and some number representing the Z coordinate. Okay, so then the task is to construct a vec3 from these bits and then push it onto our array. So components 1 will be the components 1 will be the X coordinate. We'll just go value of. So I'm using the number class in order to get the conversion function, but then I'm just bouncing it down to its primitive value. Okay, so 2 will be the Y and 3 will be the Z, as we can see there in that array. So we've got that new vertex. Now let's just go the vertices, push on that new vertex. Okay, very nice. So now we will almost do exactly the same thing for the other two. Now, if you want to be really fancy, we should probably give these more meaningful names and not just vertex for each of them. So this will be, look at this, I'll have VT as my first bit, and then the U coordinate and the V. And that's it. So this will be a vec2, and I'll just read off 1 and 2. Okay, then I'll push that onto the VT array. Excellent. And then, yeah, normal's going to work pretty similarly. So for the normal, I'll have Vn as the first component, and then the X component of the normal, Y component of the normal, and Z component of the normal. And yeah, very, very straightforward, thankfully. Okay, so that's all fine. That's all fine. Then we want to look at reading the face line. So I'm a little paranoid, so what I'm going to do before anything, because I have had trouble with this in the past, is sometimes I find that the last line of the file, for whatever reason, just has an extra new line character on it, even though the splitting operation should have taken care of that. Let's just do this anyway. So let's go, repeat. So if I see a new line character, just replace it, just blank it out. Okay. So if I look at this, I've got, on this line, everything's separated by spaces. So I'll go, I'll call this vertex descriptions. And now things are a little funky. So if I were to look at this array, the first element would say F. The second element would be a bunch of numbers separated by slashes representing the first vertex. This is actually a combination of the vertex, the texture coordinate, and the normal. And it's based around 1, not around 0, so I'll have to correct for that. But then we'll have the thing for V2, and then this will continue. Now, this is described in a bit of a weird way. It's basically the points around the edge, and I'm going to interpret this as a triangle fan. So just be 1 second. Okay, so where was I? Imagine we've got 6 points. 1, 2, 3, 4, 5, 6. Okay, then this would be described in a line. The first part would say F, then we'd have some sort of description of vertex 1, 2, 3, 4, 5, 6. Now, I'm going to break this down into triangles. And in order to do that, I'm going to need to know which of these points is my point A, B, and C. So let's say we make the first triangle. We'll go A, B, C. So that's these points here. That's the first triangle. Put a 1 there. Then for the second triangle, we could actually sort of do this however we want, but the way I'm going to do it is I'm going to keep that anchor point at 1, and I'm going to progress the B and C points off by 1. So that's A, B, and C. So that's point 1, point 3, and 4. Those ones together. That makes triangle 2. And then I'm going to keep the anchor point and progress forwards. So now we've got point 1, point 4, and 5. There. Okay. So that is the method that I'm going to use. And I mean, in my experience, I've seen polygons defined in these files which have like 20 corners. So this is like non-trivial. Anyway, so I guess we need a few things. We need to know how many triangles are in here. We've got 6 vertices and 4 triangles, and it turns out the number of triangles is always 2 less than the number of vertices. Because if you think about it, it takes 3 to make the first triangle, and you add on 2. Sorry, when you add on 1, okay, what am I thinking? 3 vertices to make the first triangle, and then when you add on another vertex, you implicitly are adding another triangle. Add on another vertex, that's another triangle, and so on. So the number of triangles is the number of vertices minus 2. Okay, anyway. Okay, so I'll make a variable called triangle count, and that will be the number of things there. Now it would be minus 2, but I'll actually make it minus 3 because we're also including that f in the line. Okay, no worries. And then what I want to do is I want to go for, I'll loop through, so variable I, 0, I less than triangle count, like that. And I'm actually going to make another function which will take one of these descriptions, like this 1/1/1, and work on that individual piece. So I'll call that function read corner. And that will take what I'll call a vertex description, and also the array that we need to bounce it, that we need to store it into. So I'll write that function first and then show you how it works. So what I want to do is I want to take one of these descriptions, split them based on the slashes, and extract that info. So I'll say, okay, make a constant variable. I'll call it very imaginatively vt_vn. And I'll split the line based on the slash. Okay, excellent. Then I'll use that to get the actual vertex that we're talking about. So we'll reference into our vertex set, and I'll do the same trick where I convert this to a number. Yeah, take the 0th bit, get the value of it, and then to correct for that 1 based indexing, I'll just subtract 1. Okay, so that will be the vec3, the actual vec3 that this first bit of each corner is talking about. And then similarly, I'll have the vt go, and I'm not going to touch the vn. I've stored it, so in future if I want to add that information in, I've got it, but I won't use it right now. So let's take the result and push in the components of the vertex and the texture coordinate. There we go. Excellent. So what this is doing is I take a little string, which is a bundle of these numbers together, and I throw it into that function, and it does its thing, unpacks it, and stores it in our result. So anyway, so I'll have my anchor point, the position of which never changes. And then I'll have the B point. What am I thinking? What am I doing here? That is, yeah, grabbing the vertex description. Anyway, then I'll have my B coordinate, which starts at a value of 2 and shifts across by 1 every time. So I'll go 2 plus I. And then similarly for the C, we'll have 3 plus I. So the anchor point is fixed and the other points are drifting, and that'll go around and do the whole thing. Okay. Excellent. So let me just go back over that. So we store the corners, and that will store all the corners in the face. And yeah. Yeah, okay. So fingers crossed this is working. It should be. Okay, so I'll just close this down for now. And I'll go back to the renderer class. Actually, I'll go back to the model first. So I'll go to the model and I'm going to make a new file called statue. And this will be very similar to the triangle. So I'll just grab everything that I've got here in triangle. Yeah, okay, looks good. So just take in a general, general vec3. So I'm just slightly modifying this. I don't think I'll actually need this, but why not? So I'll rotate around the y-axis by... Its part might not be too interesting, but anyway, so that's set up. I'm just going to call that a statue class. Okay, cool. So let's go back to the scene and declare a statue. So we make everything, and then let's go. So for the position, I'm going to be very unimaginative, because we can always mess around with things later on if it doesn't look right. Okay, great. So now I'll just go back to the update function down below. Okay, make everything. Then let's update. So okay, good. All right, so now every frame, the object data array will be storing the model transform for that statue in the position just after all of the triangles and quads. So I can go to the renderer and actually get things set up. So let's close that down. Oh, did I forget? Whoops. Okay, let's go to the object mesh, and that is, yeah, it's an object mesh class. Okay, I'm losing it. Okay, yep, import object mesh, and then I'll go right down to the assets, quad mesh. Now I've got, I'll just keep going down, set up device, all of that. Okay, so I'll say this. Okay, so I'll make the new object mesh, and then I'll initialize it. So I'll put in the device, which is the device, and then I'll put in the URL, which is the dist folder, models, and I'll just go with ground, because if there's any errors, it's better to have an error on a small file rather than a really large file. We can always scale it up later. Okay, I think that's fine. All right, so then I'll go down to the render. That shouldn't be triangles, it should be quads. But anyway, then I'll go down and I'll do the statue. So I'll set the vertex buffer to the buffer of the statue mesh. Then for the bind group, let's go with the triangle material, because that's the that'll stand out from the ground anyway. So this first argument is a number of vertices, which is the statue mesh's vertex count. And then I'm going to draw one of them. So for the instance count, I'll just go 1. Okay, so moment of truth. Let's go npm start. And yeah, I mean, it looks a little dodgy, but yeah. Oh well, I guess maybe the model wasn't originally set up properly, but point is, that's working. And now let's go to the grand reveal. So just step back, and instead of, instead of the ground, let's load the statue. Oh yeah, that's looking better. So now we have waifu domination. Yeah, so cool. So this is actually quite a big file, and it's very cool that it loads and works. Nice shoes. So yeah, that was an example of loading object files. Yeah, hope you had fun. And yeah, all the best, and I'll see you again soon.